Hello, myself is Mr. Jayesh Mohan Rao Sarvade. Today I am going to present the topic inheritance used in C++. So firstly we will see what is the meaning of inheritance. It is a mechanism of deriving a new class from an old class. Newly created class is called as the derived class and old class is called as the base class. This is the definition of inheritance. Now see what is the meaning of this inheritance. So it means a derived class can acquire the features of base class. The features are in the sense of properties and functions. Properties are the data members and functions are the member functions of that class. So whatever the classes we are deriving from the base class, that class acquires or gains the features of base class. Plus in addition, while defining that derived class, user can add some new features to it. So this is the meaning of or mechanism of inheritance. So let us see some examples on the inheritance. In the first example you can see the shape class is there, which is acting as a base class, and circle class which is immediately derived from that shape class. In the second example vehicle is there and car class is derived from it. In the last example fruit class is acting as a base class and mango class we derived from the fruit class. Whatever the classes we derived, so all those are inheriting the properties of their base class respectively. So this is what the examples of the inheritance which I gave for the better understanding. Now we'll see what are the types of inheritance. In C++ we have single inheritance, multiple inheritance, multi-level inheritance, hierarchical inheritance and hybrid inheritance. Let us discuss one by one each and every type used in C++. The first type of inheritance is single inheritance. This is the mechanism of deriving a single derived class from the single base class. It means there is only one base class and only one derived class. In this example you can see A is the single base class and B class which is derived, it is also a single. Whatever the picture you can see, this type of inheritance is called the single inheritance. Now the next type of inheritance we'll see the multiple inheritance. It is the mechanism of deriving a single derived class from the several base classes. It means there are number of base classes. By combining the features of all these base classes we create only one derived class. In picture you can see A and B are the base classes, multiple base classes, and C class which is derived from A and B. And the next type of inheritance is multi-level inheritance. It is a mechanism of deriving a class from another derived class. Let me explain this definition. You can see this example here. A is a base class and B is a derived class which is derived from the A, but B class which is derived, it is acting as a base class for another class, that is C. So this type of inheritance is a multi-level inheritance. There is no limitations for making the levels. You can derive or you can use or go for any level depending on your requirement. The next type of inheritance is hierarchical inheritance. We have seen multiple inheritance. In multiple inheritance there are several base classes and only one derived class, but the picture is exactly opposite of that. Here there is only single base class, and by inheriting that class we can create any number of derived classes. In picture you can see C is acting as a base class and A is a derived class. A class inherits the properties of C, as well as B is also inheriting the properties of C class. This kind of inheritance is called as the hierarchical inheritance. The last type of inheritance is hybrid inheritance. There is no specific format or particular type of syntax, so it is just combination of multiple inheritance and multi-level inheritance. In this picture you keep apart D class to side and then see the picture. You can see A, B, C. This kind of inheritance we have seen here, multi-level inheritance. And one more scenario is there. You remove this A class from the picture, then you can see B, D are the multiple classes and C class is derived like this. So by combining multiple and multi-level, we derived hybrid inheritance. Now the syntax is very important part for implementing the programs on the inheritance. So syntax for defining base class is, it's very similar like base class or normal class definition. So but just there is one new concept in base. In normal class we used mostly private access specifier, but here we introduce the new concept, that is protected. So after completion of this syntax, let me complete this syntax, then I am going to tell what is the meaning and what is the purpose of that protected access specifier which has been used in the definition of base class. So the syntax for defining derived class is, what new added here is this, the defining derived class, it is keyword, then name of the derived class, then use the colon, then visibility mode can be public or private, and the name of the base class. For example, class, here you write the name of the derived class which you are going to derive, and then you write the visibility mode, it can be private or public, and here you write the name of the base class from which you are going to derive, that name you write here. Here you can use protected as well as private. If you are going to derive one more class from this derived class, then use the protected, otherwise if we keep it as a private, so it is also okay. And other things are like variables and functions are defined under the protected access specifier as well as under the public specifiers. And as the syntax tells, close the curly bracket and give the semicolon at the end. So this is what the syntax for deriving the new class. Let us see one example for this. So this is the definition of base class. It is like a normal class definition, class keyword, then student, name of the class. Here student is acting as a base class, and as we know key private members are not inherited, so we are using here protected. So protected, under the protected, roll number and name we declared as variables, and under the public section we used get and put two member functions. So this is the definition of base class student. Now engineering student class is derived publicly from student. Here just one functionality extra added is branch. Now let us see what inheritance exactly does here. So as we know key roll number, name, get, put are the members of student, so still they are present in the engineering student class, as this class is derived from the student. So as its definition suggests, key engineering student is publicly derived from the student, so whatever the features we are having in student, all those are inherited in engineering student class, and it allows to add some new features also, like branch is added here, accept is added here, and display is added here. It means we can create the object of engineering student class and can access the members from student class as well as the members from engineering student class. So this is about the syntax and one example we discussed. Now see, while learning the syntax of derived class, I said ki there is a introduction to the new access specifier. As we know, private and public, these are two access specifier used in C++. We have made use all of the private and public, like private members are only accessible only for limited portion, or you can say they are accessible only within the class in which they are private, and public they can be accessible throughout the programs. So here consider one scenario, A class is there and B class we are deriving from the A, and if in A we create or use private keyword, then private members are accessible only for A, but we want to access these members inside B class also, then what should be done? Then we can make them as a public, but as they are private, so they are not inherited, because the scope is only for A, so we can make them as a public. But if we make them as a public, then the main feature of object oriented programming, data hiding, which is not achieved, because they become visible to each and every part of the program. So to overcome this problem, what we are doing is we are using, or we are making them as a protected. So as they are made protected, so they are accessible in that base class as well as the class which is immediately derived from that base class. So this is what we have seen about the protected access specifier. So as the protected members are not inherited, so we are making them as a private. Then at the end we see what are the advantages of inheritance. We can reuse the features of base class into the derived class, so it gives the reusability. Then extendability is there, you can extend the existing class by adding new data and new methods. In derived class we can add some new functionality, so it gives the extendability. And the last one is modify. You can modify the existing class by overloading its method with our own implementation. We can use the concept of function overloading and method overloading, which will be discussed in next session. So these concepts are used to modify. So all these are the advantages of inheritance. Thank you very much.